Okay, we're going to be looking at translating the circle. And the circle, or at least a full circle on a graph, isn't technically a full function because if we take a look at it, it doesn't pass our vertical line test. But we can still play around with the circle on a graph and figure out what variables and values will move it around. So I've given it four unknown numbers and we've given them variables to represent them. And really you could have called these A, B, C, and D. I use letters that we're used to looking at in translations of functions. You can tell they're not in order, and that's because I started, I guess, our variables in alphabetically. So our K value gives us horizontal, and it technically gives us horizontal stretches, okay, and compressions. Our D value is going to move our circle left and right, okay? And we have our arrows saying left and right. I'm going to move our stretches and compressions just because I want to fill in some of the information. Our A value gives us vertical stretches and compressions. I'm just going to call it SC from now on. And our C value gives us vertical translation, so moving the entire circle up and down. So we're going to build our rules, and I've kind of set up what our parameters are, where really our functions switch. The first thing we need to realize is that the number that we're equal to is essentially the radius squared. So r is the radius of the circle. So if we go over and take a look here, and I've given all of these letters, here's kind of our parent function. I've given all these letters values. If you write it into an equation, this is what it would look like. X squared plus y squared, and that's because k is 1, and we don't need to really write that in. A is 1, we don't need to write that in. C is 0, y plus 0 is just y, and d is 0. X plus 0 is just y. And our radius is 3. Well, 3 squared is 9. So if we take a look, there we go. So the center of our circle, this D and the C value are the center, is right at 0 and 0, just right at the origin. And the radius from the origin is 3, as you can tell by all the values we've highlighted. I'm going to move that now. Okay, and if I play with the radius, if I make it larger, it obviously becomes a much larger circle, and make it smaller, it becomes smaller. Now, at one value, 0 doesn't exist. Okay, there is no radius to it. And when we go negative, it starts doing the same thing over again. And that's because a negative value squared is still a positive value. Okay, so for instance, negative 3, if I can get it, negative 3 still gives us the same thing as equal to 9, as you can tell. I just opened the blue one over the red one. You can zoom in. Actually, so that's important to know about the radius. Let's move it back to the value of 3. Okay, next, let's move the D value. So as I move my D value, okay, this direction here, as you can see, the entire, and I'm going to turn these two off, the entire center of the circle is shifting. In fact, I'm going to move it to the value of 4. Okay. Now, what I want you to realize here is the D value. That would actually read x minus 4. And if you take a look, the blue one will now be right on top of it. And the negative value actually moved the circle in a positive direction. Okay. So the actual center of the circle, the x value is positive 4, and the y value is still 0. We didn't move it up and down. And that's because there's a negative in the function here. So when d is 4, we write it in as x minus 4. Okay, let's keep that idea. Our c value, let's move our c value. Same idea, let's move it in a negative direction. And as you can see, a negative direction moves it downwards. So let's move it to maybe 5. Okay. And a negative direction, okay, negative 5, that makes sense if you're going down. But if I were to type it into this equation, it would actually have to be written as y plus 5, okay? If you notice, the blue one just jumped right on top of where the red one is. And that's because we have y subtract negative 5, so it becomes essentially a positive, okay? So let's go back to our two rules here. When our D, and what we're going to talk about is the entire value of D, okay, including the sign in front. When D is positive, the circle is going to move to the left, okay? And when D is negative, and that's an entire function, it's going to move to the right. And essentially, it's counterintuitive. When it's positive, it moves to the left, which is a negative direction, okay? And when it's negative, it moves to the right, which is a positive direction, okay? And that's the same idea with our C value. Our C value, because it's vertical, when it's positive, it actually moves. And we're talking about the entire C value, okay? I'm talking about in the entire value inside the bracket. When it's positive, it goes downwards. In other words, a negative direction again. And when it's a negative value, it's positive. It goes up in a positive direction. So anything within those brackets is kind of counterintuitive. Whatever positive or negative symbol you see, we kind of do the opposite. And remember, D is horizontal and C is up and down. Okay, so we've made 4 of our 8 little rules here. The next 2 values we're going to play with, and let's move these back to C at 0 and D at 0. There we go. Okay, and we'll turn these off. And if you notice, when I make this value 0, it jumps back to the y-axis, and this 0 right back to the origin. Perfect. Okay. The next value we're going to play with here is our k value. Okay. As the k value gets larger, and I can actually push play and you can watch it, it's going to be vertically stretched. Okay, and when you think of it like an elastic band, and when it gets smaller there, okay, now this part, we're not going to be really working with negatives, so I probably shouldn't have showed you that. But when we get back to our 0, all right, this is important. Between 0 and 1, it's been vertically compressed. So think about like a weight pushing from the top and the bottom. And when we're in between 0 and 1, anything like 0.2, 0.3, can move slowly. As you can see, it's getting compressed and compressed. Think of like something squishing it from the top and the bottom. And as we go greater than 1, okay, it's like something's coming, it's pulling it up and down. Now these points don't change, but it's becoming much thinner, okay? So as our k value increases, we can write that rule there. As our k value is greater than 1, we get a vertical stretch. Okay, and when we're between 0 and 1, we get a vertical compression. Okay, let's move the radius of this over. I want you to think of it like this, where the circle's getting thinner, almost like a vertical oval, and a vertical compression is the opposite idea. It gets wider like that, our circle. So we're getting pressure from this part and this part, and here we're getting pressure from this part and this part. Okay, with that being said, let's put our k value back to 1. Let's take a look at our a value. Same idea. So as a gets greater, push play here, we get a horizontal stretch, okay? And then we get a horizontal, when we're between 0 and 1, a horizontal compression. So a horizontal stretch is, think of it like it's being pulled out this way, left and right. So it's being stretched that way, okay? And when we get between 0 and 1, we get a horizontal compression, like it's being squished inwards, okay? The whole thing's being squished inwards. Okay, so let's put it back to 1. So we've now made all of our rules for our circle here. And we'll take a look. So in a is greater, we get a horizontal. Let's take a look. This greater one, we get a horizontal stretch. Think of it like it's being pulled left and right. Okay. So our circle, it's a tougher idea. Yeah. Think of it like the circle is actually being pulled out this way and this way. And I guess with the vertical one, you can think of it like that, as being pulled up and down. I shouldn't have shown horizontal movements here. Let's move those there. It's getting pulled up and down. And for our between 0 and 1, we get a horizontal compression. Okay, and a horizontal compression, our circle's doing this and being pushed in horizontally. Okay, so think of it again. For k values, vertically pulled upwards. And when they're between 0 and 1, we're getting vertically squished. When horizontal is greater than 1, we're getting horizontally pulled outwards. And when it's between 0 and 1, we're getting horizontally squished inwards. Okay? So these are our rules for translating